Hi, I'm Camila Mustafa, and I'm from Plantation, Florida, United States. And I'm so excited to share with you what I believe to be the next solution to the blood transfusion crisis we are not only facing in the US, but across the globe. Over the past decade, there has been a dramatic increase in the demand for blood transfusions, and unfortunately, the actual amount that's actually donated does not meet this demand. In fact, in January of 2024, the American Red Cross actually declared a state of emergency due to the lack of supply. And this really highlights the need for an alternative that can not only be mass produced, but that can perform just as well, if not better, than red blood cell transfusions at improving oxygen capacity in patients who need it the most. Now, the next biggest thing in terms of research endeavors is to turn to nanotechnology as a potential solution to this problem. Silk fibrin from Bombyx mori, more commonly known as the silk moth, is biodegradable, biocompatible, and can easily be manipulated, making it popular in terms of research endeavors and specifically a great candidate for synthesis of nanoparticles. Now, the objective of my research was to evaluate the biological identity of these silk fibrin nanoparticles, and the biological identity of something like a silk fibrin nanoparticle is characterized by the reaction of our bodies to its presence. So when these silk fibrin nanoparticles enter a medium like our blood plasma, it comes in contact with plasma proteins, and these proteins can form unique interactions with the surface of the nanoparticle, and hypothetically form a structure called a protein corona. Now, to evaluate the impact of this protein corona, I looked at changes in particle size, surface charge, and whether or not macrophages were activated to the presence of these silk fibrin nanoparticles that will have this theoretical protein corona around them. In addition to this, I looked to image these nanoparticles under a scanning electron microscope to observe any morphological changes visually. I was able to find that the plasma proteins interacting with the surface of the nanoparticle are not causing a sizable difference in surface charge or average particle size. And finally, I was able to find that macrophages are not adopting a strong pro-inflammatory phenotype in response to the silk fibrin nanoparticles with these protein coronas around them. Thank you.